Hey guys, welcome to College of Engineering and Computer Technology. I'm Engineer Jason Paul Busencio, and today we'll be discussing and presenting the Electronics Laboratory series. In performing our Electronics Laboratory series, now we will be using the following modules and measuring equipments. First, we have here the microcontrol module. Next, we have the logic circuit module. And we have here the wave shaping circuits module. And along with that modules, we also be using these measuring equipments. First, we have our digital oscilloscopes. These digital oscilloscopes will be used to measure and display our signal waveforms. Next, we have here our signal generator, which is used to generate AC sinusoidal signals, triangular waveforms, and square waveforms. Next, we have here our digital clock meter, and finally we have here our multitester. So for today's laboratory, we'll be performing laboratory activities on wave shaping circuits. So what are wave shaping circuits? So wave shaping circuits are one of the applications of our diode. It has the capability to alter or change our input signal waveforms. So for the first part of our laboratory activity on wave shaping circuits, we'll be performing activities on rectifiers. So rectifiers has two types. We have the half wave rectifiers and the full wave rectifiers. So to perform or to display our half wave rectifier, we will now be using the following components and equipments. First, we have our diode. It's a general purpose diode, 1N4001. Then we have here our resistor. So any resistor will do, but now for this activity, we will be using a 1 kilo ohm resistor. Next we have here our connecting wires, our breadboard, and to serve as our input signal, we have here our signal generator, and to display our waveforms, we have here the digital oscilloscopes. So to perform the experiment, so let's get our diode. Let's put the diode on our breadboard. Then the resistor, our 1 kilo ohm resistor, so we should connect it to the cathode of our diode. So the reference for the cathode of our diode is where the silver mark is. So let's connect in breadboard. And that's our circuit, our half wave rectifier circuit. Before we connect our equipment, so make sure these are properly calibrated. For our signal source or for our input waveform, so we will using our signal generator. So this display is the frequency of our signal. Then from here, from these top buttons, we can choose what type of signal we will be using. So there's a sinusoidal waveform, triangular waveform, and a square waveform. So for this experiment, we will be using a 1 kHz waveform that is sinusoidal. Okay? So let's connect our input. So the positive side of the probe, so we should connect here on the anode of the diode, and the ground or the common should be on the other side or other leg of the resistor. That's our input. Then to display the waveform of our input signal, so we'll be utilizing the channel 1 of our oscilloscope. So let's see. So as you can see, it is a sinusoidal waveform with amplitude of 9.3 volts and frequency of 1000 kilohertz, which is equal what is displayed on our signal generator. Then to display the output of this circuit, we should connect our probe or our output probe to the resistor. It should be connected parallel to the resistor. Then that's our half-wave rectifier. As you can see from our original waveform, as long as the signal enters our circuit, it has an output of this. As you can see, the other half of our waveform is being cut off.
Oh my God! Wow!
So, our half-wave rectified signal, as you can observe, from the frequencies of the two, from the input to the output, if you can notice, the channel 1 or the input frequency is 1.02 kHz, while the output frequency is 1.02 kHz. It only signifies that the output waveform or the output frequency of a half-wave rectifier is the same as the input frequency. This type of half-wave rectifier is the positive half-wave rectifier, wherein the signal cuts off the negative cycle and it lefts the positive cycle. So if we want to invert the half-wave rectifier, so we will just change the orientation of our diode. So we'll just connect the anode of the diode to the resistor. As you can see, when we change the orientation of our diode, so the orientation of our half-wave rectifier also changes. From the positive half-wave rectifier, it now became a negative half-wave rectifier. For more videos about electronic system, please like, share, and subscribe our channel.